that we have performed on 2D objects, the same thing is needed to be performed on 3D objects. But obviously we are getting one more axis, and but obviously you'd be getting one more value. So dimension would change, and somewhat like matrix will change. So we will see all of these operations, and we'll see which are the things that we can perform on any 3D object. Okay, so transformation, in the transformations, like we have this many things, that is translation, rotation, scaling, and few other operations that we have seen, that is reflection and shearing and all. And then viewing pipeline, coordinates system, and then projections, and view volume and general projection transformation. Okay, so we'll start with the very first thing that we have, and we will try to finish how that is translation, rotation, and scaling. Okay, in today's lecture. So very first thing that we have is the 3D translation. Yeah. So now, as you can see on your computer screen, we have one figure that shows us how we can perform this thing. And but obviously now it is a translation. So what we are doing is we are just taking this thing from one position, and we are just putting this thing or moving it to some other location, you can say position. We are not actually distorting its shape or something, or we are not at all rotating it. So similar to the 2D translation, which we have already performed using this 3x3 matrix as it is written in the first line, 3D translation uses 4x4 matrix. But obviously one more thing that is added is Z point. Okay, so we have this added information with us. So now whatever things we have seen, we just need to extend the same thing, and we have to apply the similar thing in this 3D translation. So we will see how we can do this thing, or how we can achieve this thing. So in 3D translation, point XYZ is to be translated by, but obviously you'd be given this information, or you require this information where you want to translate the given things. So three such things over here will be, if we talk about translation, will be TX, TY, and TZ to location. There is the updated location, that is X dash, Y dash, and Z dash. Okay, and similar thing is to be applied. You don't have to put any other thing over here. You just have to add this required information, or the things that you want to add, that is TX, TY, TZ with our coordinates. And the new coordinates, or the resultant things that you'd be getting out of it, is X dash, Y dash, and Z dash. Okay, so now the new parameters that you will be having is X dash, Y dash, Z dash, and that you can calculate it with the help of the given thing, as you can see on your computer screen. Okay, and yeah, similar thing can be represented in the matrix form, and this is how it will look. Okay, so one we have written here because of X, similarly one here for Y and for Z. Okay, and all of this thing is needed to be multiplied with the like the coordinates that you have in your hand, or the operation that you want to perform on. So this is how our matrix will look like, and yeah, so we will see this thing, and we will perform a simple operation, and we'll see what is the resulting thing that you are getting. So one thing that is given over here, that is translate the given point P, that is 10, 10, 10 into 3D space with the translation factor T, and 10, 20, and 5. Okay, so similar operation is to be performed in this example, and the matrix that we already have is this thing, that is 100 TX, 010 TY, 001 TZ, and 001. Okay, into XYZ 1. So this is nothing but your given thing, okay, on which you want to perform the operation. So as you can see, yeah, similar thing is to be like replaced as the translation factors are already given, that is TX, TY, and TZ, and that is to be replaced by the given thing. In our example, we have 10, 20, and 50. Similar thing has been like replaced over here. It is very simple. You just keep your eye on it, and then similarly operations have been performed. That is a column has been multiplied with the first row, second row, and likewise. Okay, so these are the basic things that we have, and the resultant thing out of which we are getting is 20, 30, 15, and 1. Okay, so this is what you can do in 3D translation. Okay, so final coordinates, whatever you are getting, you just have to write it in your exam, and you just need to find it. Yeah. So now This was a very simple thing, but whenever we talk about rotation and other such transformation, then we require like so many things. So we will see the same thing. And but obviously, if we talk about rotation, then we need to pick an axis to rotate about. You can be going in an arbitrary direction also, that is fine. But if you have this like if you have this information on which axis you have to rotate, then it will be relatively simple. Okay, so a general scenario is given over here. That is how it will look. Okay, if you want to rotate about an particular axis. Okay, so one such information is given over here. So similar thing is you can do with x and y axis. Okay, so we will see each and every scenario in detail, and we will try to understand it, how we can perform these operations. And once we are done with the simple operation on this xyz axis, then we can see how we can perform it about an arbitrary axis. Okay, so now the most common choices are x, y, and z axis. It is known as coordinate axis rotation. Okay, a simple term. In a simple term, you can consider if it is given that coordinate axis rotation you have to perform, and choice could also be given to you, or you can use it for your own application or for your own purpose also. So very simple thing that is written over here, and we can also choose other arbitrary axis for rotations. Okay, but then the dimensions and the equations would change. Okay, the very first thing, as you can see on your computer screen, that is z axis rotation. Okay, so now two-dimensional rotation equation can be easily converted into 3D z-axis rotation equation. How? That we will see. What it says is rotation about z-axis will leave z coordinate unchanged. Okay, so if it says that we have to leave the z coordinate unchanged, then we will get something like this. So whatever information we have at the z-axis, you just have to keep it as it is. You don't have to perform any such thing on that particular thing coordinate, and we have to take the same thing that we have used in like 2D concept. You just have to put the same thing over here. It is for x, we have to take x cos theta minus y sin theta. Similarly, for y dash, we need to perform this thing, that is x sin theta plus y cos theta. Okay, and angle could be anything. You can specify your own thing, or if it is given, then you have to take it. So this is what it will look like after the final thing that you are performing on the given coordinates. Okay, so it will look like this because we have left z coordinate unchanged. So cos minus sine, and similarly sine cos, and 0 0 1 0 0 1. This is our homogeneous coordinate. Okay, into x y z and 1. Okay, so the things will the thing will remain same over here. You just need to understand the how you can perform the rotation about that particular on that particular axis. So for z axis, you can just take this readily available thing, and you can put it in your example. Okay, so now once we see all of this concept for like z axis, y axis, and x axis, we will see one simple example. By that you'll get an idea. Okay, but if you have this thing, then you can easily perform. You don't have to like apply any logic if simple thing is given to you. Okay, if it is not about an arbitrary thing or arbitrary line or point, you can consider. So now x-axis rotation. So what it says, so transformation equation for x-axis is obtained from the equation of z-axis rotation, okay, by replacing cyclically as x, y, z, and again x. So how it will be represented, or how we can perform this operation. So over here what it says is rotation about x-axis will leave x coordinate unchanged. Okay, and whatever thing we have to perform is on y and z coordinate. So for that we have this information with us, that is y cos theta minus z sin theta. Similarly for z dash equal to, for z dash we have this thing, that is y sin theta plus z cos theta, and x dash equal to x. Okay, and but obviously you need this theta information for specifying the rotation angle. Okay, so similarly you can write it in the matrix form. and the same is given over here. So the very first thing that you gotta do is what it says is like we have to keep the x coordinate unchanged. So if it says so, we have to do the same thing there. So that's why we have written it like this. That is 1 will remain over here and then 0 0. Okay, because we have not changed x coordinate. Similarly for y and z, we have to put the required thing over here. So in our case we have cos theta and minus sine theta, similarly sine theta and cos theta over here. So and then you just need to remember this matrix, nothing else is needed to be done on your side, and but obviously the respective axis rotation. Okay, so this is the general thing that we got if we want to perform it on x-axis. Okay, yeah. So now for y-axis, transformation equation for y-axis is obtained from the equation of x-axis rotation by replacing cyclically as x, y, z, and again x. So now to do so, what it says is rotation about y-axis will leave y coordinate unchanged. Okay, and the thing or the coordinate for a particular coordinate, what we require is for z and for x. So z dash can be calculated by this thing, that is z cos theta minus x sin theta. Similarly, x dash can be calculated by z sin theta plus x cos theta. Okay, and y is to be kept as it is. Okay, so that is how we can do it. And similarly, we gotta put all of this thing in the matrix form, keeping y as it is. So if we keep y as it is, you can see in the second row we have 0 1 0. Okay, and similar thing has been taken over here. Okay, because if we are considering this thing, so then we have x, y, and z. If we take it in that form, then we have minus sine theta and cos theta over here. And similarly for x dash, we will put the same thing in the matrix form, that is cos theta and sine theta. And all of this thing is needed to be multiplied with the coordinates where you want to perform your rotation operation. And once you perform it, you will be definitely getting the resultant thing after the rotation. So these are the general thing, the same thing that we have seen in the 2D concept. You just need to expand it and you have to take this thing technically. So yeah, so these are the three things. A simple rotation, if you want to perform, then you can do the similar thing. Okay, so that is x, y, z axis rotation. Now example, one simple example is given over here. What it says is rotate the point P, that is 5 5 5 90 degree about z axis. So now you just have to take this like matrix from the PPT and you have to put your calculation, you have to do all the calculations, and then you need to find the resultant matrix. So now for this thing we have theta with us, and point is also given to us, that is x, y, z, and we'll put all of this thing together to calculate this thing. So yeah, so keeping z coordinate as it is, so it is nothing but 0 0 1. Okay, as you can see over here, and remaining is the homogeneous coordinate. And then multiplying all of this thing with the point that is given to us, that is 5 5. Okay, and the resultant thing you'd be getting is minus 5 5 1. So this is just a simple calculation that you can perform on any given thing. Yeah, so this is coordinate axis rotation. Okay, so yeah, so similar thing is over here as we have seen in the previous lectures, okay, of CG. Now a little bit tricky side is nothing but general 3D rotation. Okay, so what if a general 3D rotation is given to you, or if you are encountering this kind of situation? Okay, so for that general 3D rotation, what you gotta perform, so that we will see now. Okay, the first scenario that you can encounter, you might get into, is this thing, that is when rotation axis is parallel to one of the standard axis. Okay, when rotation axis, try to understand it, when rotation axis is parallel to one of the standard axis. So standard axis, if I say, that is nothing but x, y, z. So if this is the case, then 3 steps are required to complete such rotations. Okay, So very first step that you have to perform is translate the object so that rotation axis coincides with the parallel coordinate axis. Okay, so you have to translate it in such a way that the coordinate that the rotation axis coincides with the parallel, or you can say that it goes into this thing that is the parallel coordinate axis. The second thing is to perform the specified rotation about that axis. Okay, and to perform such rotation about that axis, so if you are with any of the standard axis, then the equations and the matrix you already have, you can just take it and you can perform your operations. And then third thing is translate the object so that the rotation axis is moved back to its original position. Because it's not like that whatever operation you are performing and then you are like getting away from the given thing. So you have to put it back to its original position. Okay, the whole of thing can be represented as given over here. So we have to take inverse, we have to rotate this given thing about that particular axis and then perform the translation. Okay, so that it gets back to its original position. So this is about one thing, that is general 3D translation. Okay, but now we have one more thing over here. What if this case is encountered? So when rotation axis is inclined in arbitrary direction, so now we don't have any such information, it is totally random, then what to do? So we have a series of steps to perform, and once you get this thing, then you just have to follow this sequence to get it in this random direction that you might encounter. Okay, so we will see this thing now. So what it says is, first we need rotation to align the axis with the selected coordinate axis. So first we need rotations to align the axis, okay, with the selected coordinate axis. Okay, selected coordinate axis, that means you can go with x, y, z, and to bring the axis back to its original orientation. Okay, so to do all of this thing, we require 5 such steps. Okay, try to imagine this thing also. Okay, wherever required, there is a diagram to understand it in a better way, but then you have to imagine this thing. So now 5 such steps over here that we need to see to complete such kind of situation. Okay, such kind of rotations that we need to perform. So very first thing that is given over here is translate the object so that rotation axis passes through the coordinate origin. Okay, so we have to move it in such a way, in such a direction, or you can say in such a position, so that it passes through the coordinate origin. Okay, so you can consider that you have to take it from the original location or the position, and then you have to pass it through the candidate origin. So we have this whole scenario in the upcoming slides, so you just be with me. Second thing is rotate the object so that axis of rotation coincides with one of the coordinate axes. Okay, what it says is rotate the object. Now you have to perform the rotation so that axis of rotation. So now the earlier slide says that, okay, if it is coinciding with one of the coordinate axes, so now we have to do that particular thing. So instead of taking now from the random position, we have kept it in such a position that we can get it coordinate information. Now what it says is you have to perform one more operation, that is the rotation operation, so that object, so that axis of the rotation coincides with one of the coordinate axis. So if you are taking it from x, you have to rotate it in such a way that it coincides with y-axis or z-axis, whatever thing is given to you. So we will see the same thing in the next slide, and then perform the specified rotation about that coordinate axis. So if it says that specified, you just perform the specified operation about that coordinate axis. So the thing we already have seen for x, y, and z axis, so on whatever axis it is, you can just simply perform that operation. Okay, by using the predefined matrix that you have. And then, okay, now all of the operations that you have performed, you have to put it back to its original position. So to do so, you need to perform apply inverse rotation to bring the rotation axis back to its original orientation. Okay, so we have to perform this thing also to bring the rotation axis back to its original orientation. And then once you have done this thing, you have to take it back to its original position from like whatever random XYZ position you have taken it. You have to put it back to that original location. So apply the translation operation without affecting the rotation thing that you have performed, and by applying this thing you can put it back to its original position. Okay, so now to do all of this thing we need some information. Again, it is fine if you are like looking at this thing theoretically and you are just reading it, but what if you want to perform it in an actual scenario? So to do so we have series of steps that we will see. Before that, we can transform the rotation axis into any of the three coordinate axes. Okay, but what it says is the reasonable choice for the developers, for the programmers is z axis. Why? That we will see. And we are given line in the form of, but obviously if this is the case that is given to us, that is if we are given a line in the form of two endpoints, but obviously p1 and p2, the coordinate information is x1 z1, x1 y1 z1, and x2 y2 z2. And if this is the case, then what we can do as given, as if it is given in this slide, what are the series of operations that are to be performed. So we will say this thing and we'll try to understand it in a better way. Okay, so now yeah, we will see this procedure step by step. So now the very first thing, as it is written on your on our like slide, that is translate the object so that rotation axis passes through the coordinate origin. So as I said, same thing you have to imagine, and same thing is given over here. Okay, so now this is the thing that we want, and our two endpoints that are at the arbitrary position, that is p1 and p2, and it makes up a line. So what it says, you have to take it from that position and you have to put it over here so that it will come over here. Okay, and to do so we have to perform some operation. So what it says, for translation of step 1, we will bring first endpoint at origin, and transformation matrix for the same is as given below. Okay, so this is the same, this is a simple thing that you need to apply on the points. Or what it says, we will bring the endpoint at origin. Okay, so you just need to perform this operation at step 1. Okay, now at step 2, rotate the object so that axis of rotation coincide with one of the coordinate axes. Okay, so we need to rotate the object such that it coincides with one of the coordinate axes. Okay, so this task can be completed by two rotation, first rotation about x-axis and another rotation about y-axis. Okay, so if there are multiple operations, then our complexity would increase. Okay, but now one problem we have over here is we don't know the rotation angle. Okay, so what it says is, if you don't know, so we will use dot product and vector product. So now you try to like recall your concept of 10th or 12th mathematics or something. So we will use the same thing over here. So now what does it say? So now, yeah, vector notation for rotation axis is v, and there is nothing but a difference between the two endpoints. Okay, so x2 minus x1, y2 minus y1, and z2 minus z1. So now unit vector along the rotation axis is obtained by dividing vector by its magnitude. Okay, so whatever thing you have, you just need to divide it with its magnitude, and then you would be getting a simple like coordinate kind of thing, that is a, b, and c. So now yeah, so now we need cosine and sine value of angle between unit vector u and xz plane. Why you need this thing? Because for that to do the now we want something to be projected on yz plane, because what we want is we want the same thing on the yz plane. So to do so, for taking, or for that, take the projection of u on yz plane and like give one notation to it, that is u dash, as you can see over here. Okay, give one notation to it, that is y dash. So u has been projected on yz plane. Okay, and that has been denoted with u dash. So now find the dot product and cross product of u dash and u z. So now we have two such things for which we need to find it. First thing is find the cross product and dot product of u dash and u z. See, we are like going with some simple derivation, and then we want some metrics that will be helpful to us to do the simple operation. I could be showing you the simple metrics and then directly also, but you just it is a very simple thing. You can go with it, and even if you don't go with it, then also it is fine. You just have to take that matrix that we have at the end. Okay, so now we have u dash, as you can see over here. U dash is this line, and we have u z. Okay, and our angle, as it says, is alpha. So now coordinate of u dash is part obviously 0 b c. Okay, because we are at the yz plane. Okay, so well, like simply eliminate x, and plane x will be 0 as it is written over here. So now, but obviously, as per the dot product formula, if you are choosing, or if you are taking dot product of u dash and uz, then you would be getting this thing, that is absolute value of u dash and uz and cos alpha. This is nothing but a standard formula that has been derived in, like, that you already have in mathematics. And now keeping this thing as subject, that is cos theta, cos alpha, what we want is this information. Okay, so we need something to be substituted, okay, whenever we use cos alpha. So for that, we will just put this thing on the opposite side. So if we want to take this thing on the opposite side, you need to divide it. Okay, and once you do this thing, you will get this thing, that is u dash into uz upon whole of this thing that you have taken. Okay, and now based on the values, you just need to replace that thing with that with the value it is having. So the very first thing that you have is u dash, and its respective value is 0 b c, because it is the projection on yz plane. Okay, and similar thing that we have is uz, and for uz, for uz we will be taking 0 0 1. Okay, because we will put this thing, that is x and y value. We will take this x and y value as z, because we have just taken this thing on the z axis. Okay, and similar thing you'd be getting is 0 0 1 upon the whole thing, that is b square plus c square. There's nothing but the same formula you have to take, because our one coordinate value that we have is 0, so we will just put b square plus c square instead of taking a square, and the whole thing it will look like this, that is over here. And what it says is, now you have to just replace this value that is at the top is with c, and similarly the next value will be d, and d will be equal to under root of b square plus c square. So for simplifying purpose, we have done this thing, so we do not have to go into detail of it. And so right now we have one thing, that is cos theta cos alpha equal to c upon d, where d is equal to under root of b square plus c square. Okay, so now one thing that we have is the value of this thing, that is cos alpha. Similarly, another thing, what it says, you need to find the cross product, okay, of u dash and uz. So for doing the same thing, we have this formula with us, that is that how it can be expanded. So for the same, you have this thing, that is ux into the absolute value of u dash and uz, and then you have to multiply the whole of this thing with the sine alpha. Okay, these are the simple things that is there in your mathematics. So if you want to find it, you can easily find it. What is the cross product of two vectors? Okay, so it will give you the same thing. If you put it a into b form also, then also you're going to get the same thing. Okay, so now few things that are written in the red font, you can just read this thing. So what it says is, you have u dash value, that is 0 bc, you have uz value, that is 0 0 1. Okay, and again what we are doing is, we are taking the cross product of the two things and multiplying this thing would be like expand, or you can say the expansion of the same thing would be giving us this thing. That is nothing but a2b3 minus a3b2 comma a3b1 minus a1b3 comma a1b2 minus a2b1. So putting all of this thing over here, and similarly considering the same thing over here is a1 a2 b3, similarly b1 b2 b3, and putting the same thing in this form, you'll be getting at the end b comma 0 0. So now we have one general thing, and we got one thing that okay, if we get this thing, we can simply replace it with b, okay, or you can substitute it with b, okay. And from that we have substituted it the same thing in the second equation, that is with b. And what it says is from 1 and 2, see, we just want something to be substituted at the end in the matrix form. So in the next, or yeah, in the next slide only, we have the general matrix form that we can directly use if you want to take it. Okay, and one more thing over here is from 1 and 2, what it says, we have taken this thing that is ux, u dash uz sine alpha equal to ux into b. Okay, and yeah, so now comparing both of this thing, what it says is we have we need to find, or you need to give this thing that is sine alpha as subject, what it will be giving us. So we will simplify this thing, okay, with the things that we already have. So we will first of all substitute this u dash value, that is nothing but under root of b square plus c square, okay, and into uz. Uz value is 1 because it is nothing but 0 0 1, so we can take 1 and we can eliminate the remaining things into sine alpha, as you can see over here, and keeping this thing in the subject form, and substituting the same thing, that is under root b square plus c square with d, will be getting sine alpha equal to b upon d. So we have one more thing to be substituted, that is b upon 3. Now we have sine alpha and cos alpha, so we will write the matrix for the rotation about x-axis, okay. And to do so, what it says is we gotta put the same information over here, and this is how it will look like. And similarly, by replacing cos alpha with c by d, and similarly minus sine alpha by minus b by d, you can similarly use this matrix for your own purpose also. Similar thing we have after this is, after performing the above rotation, you will be rotated into u double dash in xz plane, okay. So xz plane, if we see, yeah, this is the xz plane, okay. So whole sort of operations we have performed on that particular line. So after performing the above thing, you'll get this thing into u double dash form, and that is nothing but it is in the xz plane with coordinate information, that is a0 under root of b square plus a square. Why we have 0 over here? Because now we are in the xz plane, okay. So now, as we know, rotation about x-axis will leave x coordinate unchanged, okay. The same thing that we have seen, if you want to perform it about x-axis, it will keep the x coordinate unchanged. So u double dash is in xz plane, so y coordinate is 0 and z component is same as magnitude of u dash, okay. So whatever value of u dash you have, you just have to consider the same value and you have to go ahead with it, okay. So now what it says is, now rotate u double dash about x-axis, so that yeah, rotate u double dash is this thing that you are having at this point about y-axis, so that it coincides with z-axis, okay. So now to do so, we have to again repeat the same procedure, okay, and you have to do the same thing to get this thing, okay. So for that, we repeat the above procedure between u double dash and uz to find the matrix for rotation about finding the matrix. And then we want something to directly that we can use in our example or something. So what it says is, we repeat the above procedure between u double dash. Instead of now taking u dash and uz or something, we are using this u double dash and this thing, okay, that is uz. So now we'll be doing the same thing. You will be performing the same operations, and with the help of dot product, as we don't know that at where or we don't have that information, so we'll be performing it with the dot product and cross product. Okay, the same thing is written over here, same sort of operations are to be performed, but now the value will change. Okay, instead of just the previous thing, we have now a0 under root b square plus a square, and but obviously u z value will remain same. Okay, so it is 0 0 1, and similar thing is to be performed. Okay, so now we are getting something over here that is nothing but d value, because we have just simply multiplied both of this thing, and then what is remaining with us is nothing but this, that is under root of b square plus c square, and that can be substituted with d. Okay, so now you keep one thing in mind, that is cos beta value that you have at this point is d. Okay, so that at the end, at the later stage, we can simply put it in our matrix form. So now the similar thing is to be done for the cross product, and where it leads us is over here. Okay, similar operations we have performed, nothing else or no other thing you have to take from the mathematical program or something. Same thing we have performed over here, and at the end you have this thing, that is sine beta value. Okay, so in this case you have this value that is same as previous thing, the same of the series of operations have been performed we did in the previous slide. So now we have sine beta equal to minus a. Okay, and now what it says, now we have sine beta and cos beta, so we will write the matrix for rotation about y axis. Okay, about y axis, if this is the case, then you have to keep the y unchanged, and remaining thing you can write it over here. Okay, and the same form is written over here, and the cos beta can be substituted with d and so on. So by combining both rotations, we can coincide rotation axis with z axis. Okay, so similar thing, you just have to put the previous two rotations that we have performed, and we can simply coincide our rotation axis with z axis by doing this two series of operations. See, abhi thoda confusion hoga. What I will do is, once we finish this topic and the remaining thing in the lecture, I will try to put one example for such arbitrary location or arbitrary position, so that you get an idea okay, which are the things that are to be performed on this values or something, if this is a scenario. Okay, because abhi kya na thoda derivation and the series of operations are getting combined, so you might get confused कि अच्छा इसके बाद कौन सा step करना है और इसके बाद क्या करना है. So I will try to put one example of the same, so that you get one idea that okay, these are the things that are useful to us and these are the things that are not at all useful to us. Okay, don't worry about it. So now the third point says that perform the specified rotation about that coordinate axis. Okay, so to do so, now it will get simple, because now remaining thing would be similar thing that you already have. So if what it says is we align rotation along with z axis, so to do so we have matrix for rotation about z axis as you already have. Okay, so you can just simply take this thing into the consideration. And now fourth step says that apply the inverse rotation to bring the rotation axis back to its original position orientation. So this step is nothing but the inverse of step 2. The two things that we have to have, you just have to take the inverse of that particular matrix. And once you do this thing, apply the inverse translation to bring the rotation. So I think we can spare some 15 to 20 minutes for example of such cases. Okay, and by that you will get more idea. It's difficult padega. Okay, now apply the inverse translation to bring the rotation axis back to its original position. So now this step is inverse of step 1. Okay, because now we need to bring, or we need to move it to its original position. So that is what it says. So these are the final sequence of transformation for general 3D rotation. So these are the things that you need to perform whenever you get any such scenario. So I will try to find some example and we will see the same thing. Okay, we have time, don't worry. We will see the same thing in an example form. And we will try to, but obviously perform all of the operations that are given over here. Yeah. So these are the things related to rotation, and we have one more thing over here that is to be done in today's lecture is scaling. Okay, so as you already know, it is nothing but to resize the object into in 3D space now. Okay, well, while the concept remains the same. So now what it says, we can apply uniform as well as non-uniform scaling by selecting proper scaling factor. But obviously, if you keep both of the factors or three of the factors that are given to you or that you are taking same, then you are going to get a uniform scaled thing. And if you don't take this thing, then non-uniform scaling could be performed. So scaling in 3D is similar to scaling in 2D. Only one extra coordinate needed to be considered. Okay. So coordinate axis scaling. Okay. A very simple thing that we will see. The simple coordinate axis scaling can be performed as below. Okay, you just have to take this scaling matrix and the coordinates that you have with you. So it will look like this: as x, as y, and as z. And you gotta put the same thing and it's over here. So what it says, scale the line AB with coordinates 10, 20, 10, and 20, 30, 30. So whatever information you have, you just put it. अभी शायद आपकी preparation हुआ होगा mid sem और उसके लिए, so you might not find it difficult क्योंकि you just need to add one more information to the matrix. So this thing will be like very simple to you now, or you might not find it difficult now because this thing you already have performed in your mid-sem exam also. So now you have to find the resultant matrix, resultant thing, that is ax dash, ay dash, az dash, bx dash, byz, and bz dash. Okay, and with the scale factors that are given to you is 3, 2, 4. So you'll be getting something like this. Yeah, but obviously your calculation would be getting a bit difficult because now you are considering the 4x4 matrix instead of 3x3 matrix. So because we have one added information with us. So now we have this thing that is 300, as you can see on your computer screen. It is 3000, 0200, 0040, and 0001. And similarly, we have the scale factors over here, and we just need to compute it by doing a simple column and row multiplication. Okay, and the resultant thing is already given to us. It is 30, 40, 41, 60, 60, 121. Okay, थोड़ा practice कर लेना. Don't be overconfident in the examination. अच्छा, it is over here. We can simply calculate क्योंकि you'll be having limited time in your like end sem exam. And you have to perform all of this thing in the limited time. So I think your ESE is like end sem exam is of 3 hours only, so you will get enough time to do all of this thing. Okay, so final coordinates after scaling are a dash and b dash. Okay, the thing that you have computed. And then we have one more thing. Okay, that is fixed point scaling. You don't want to change the position of the object that you have, and then with the same position you want to perform the operation. Okay, so we have similar things over here, and we will see this thing. Okay, so as it is written over here, it is used when we require. See, you can like similarly consider if you have board and all, then for a single topic only it will take more question, and then for simple example, so you have to do all of the calculations and you have to like do it in the runtime only while we are in the lecture. So this thing saves our time. So now fixed point scaling is used when we require scaling of object, but particular point must be at its original position. That is given over here. So by that thing you can easily understand it. So 3 such steps we have to complete such fixed point scaling, and these are translate the fixed point to the origin. Okay, scale the object relative to the coordinate origin using coordinate axis scaling. Okay, and then translate the fixed point back to its position. So if you have this kind of scenario, then translation comes into the picture. So matrix equation for doing the same thing is over here. Okay. First thing is symbol translation. Okay, so that you can take it as it is written over here. Translate the fixed point to the origin. Okay, and then the second thing you have to perform is to its listen. So performing the first option over here. The same thing. You can like simply multiply it with each other, and then the final thing you can take out of this slide is this given matrix, and you can simply use the same thing in your examination. Okay, so you try to like take some examples from the book or from somewhere, some other source, and you try to calculate the same thing and see if you're getting it or not. Okay, and yeah, that's it for today. And tomorrow we will not directly go to this transformation tech. One other transformation that we have is reflection, but instead of that, we will see one example. Okay, for the rotation, it is in the arbitrary position. We don't know the position, so we'll try to perform all of the operations that we have or that we have just now derived, and then we will try to understand it. एक बार वो देख लेंगे example, and it will be more clear to you. Okay, I think it is we don't have any such difficult thing over here. Just operations we have to perform. You have to just like multiply it, and nothing else is to be done. So these are the things. Okay. Similarly, कल देखेंगे examples from the same topic, and yeah, that's it for today. Now we don't have anything else to do. So yeah, that's it for today. If you have anything to say, then you can write it in the comment box. I think it should be clear to you because many of the things are already there in the 2D concepts. It is not new to you. Okay. Yes. Okay. Yes. कुछ तो लिखो, कहाँ हो आप लोग सब? Getting my voice? I'm planning for the same thing. That's what I was thinking in the morning, that I will try to create one tutorial based on this topics that we have seen after midsem, and a few examples I will take or I will give you in the tutorial itself, and yeah, that is fine. And from the 3D, what you can expect in the examination. Also, I will try to put some general questions in your tutorial, next tutorial. So I will do the same thing. Don't worry. Whatever things we have seen, I'm just going to take this thing in the exam. Nothing else we are going to take or we are going to consider. Okay, but yeah, you have to solve it for different scenarios if you consider. Okay, so definitely I will create one more tutorial based on the topics that we have seen or we are going to see next. Okay. Anything? Good to go. Okay, fine. Okay, that's still good. Else, yeah, that's it for today. You can leave this thing.